Hi, welcome to another edition of Smart Physics. I just wanted to do a couple of problems, maybe 3 or 4, that I think would help you, especially in you doing your assignments. Okay, here's question number 1. It's about a company that manufactures nozzles for garden hoses, and you're working on an adjustable hose. And your design calls for a rotating head that has a number of cylindrical plugs that can be inserted into the opening. Now, on a particular setting, the speed of the water passing around the plug. So that means water does not pass through the plug, it passes around the plug. And the speed of the water is 3 times as large as the speed of the water in the hose. Determine the ratio of the plug radius to the inside of the hose radius. Now, why do we need to reduce the radius of the hose? That's in order to make the water go out faster so it can go a longer distance. Now, that's what is happening here. But the most important thing in this question is that the speed of the water given is that of the water passing around the plug. Okay, definitely what we have to use here is the equation of continuity, according to which A1 times V1 is equal to A2 times V2. So if this is the diagram, a rough sketch, and that is the plug, you see that where the area is A1, the speed is V1, and where the area is A2, the speed is V2. And area is given by pi r squared. So pi r, that's the radius of the hose squared, times V1 is equal to pi times radius of the... Okay, so on the right hand side, what you see is actually the area of cross section of this part. So to get that, we'll have to take the area of the hose minus the area of the plug. Does that make sense? That's when we'll get the area of the part between the plug and the hose. So that is what is done here. You have the area of the hose minus the area of the plug. And because the velocity is given as 3 times V1, we can write it as 3V1, of course. And then the V1s get cancelled, the pi's get cancelled, and RH squared is this. And because you have RH squared and 3RH squared here, you can take this to the other side. That makes it 3RH squared minus RH squared, which is 2RH squared. And then you have is equal to 3rp squared. So on rearranging, rp squared by rh squared is equal to 2 by 3. Now take the square root on both sides and you get rp by rh is square root of 2 by 3. Which gives 0.816, and that's the answer. Okay, now on to the second one. In this question, this is about a soft drink bottling plant. A horizontal section of pipe carrying citric acid in liquid form goes from a cross-sectional area of 8 centimeters squared, where the speed is 250 centimeter per second and the pressure is 1.40 times 10 to the 5 pascals. So you have the area, you have the speed and the pressure at that point or in that section. But then it goes to another section of the pipe with an area of 3 centimeters squared. So the area is much smaller, which means the speed will be bigger. The density of citric acid is given. And for the section of the smaller pipe, we have to find the flow speed and also we have to find the liquid pressure. Okay, to find the flow speed, we're going to have to use the equation of continuity as in the last case, which is A1 V1 is equal to A2 V2. And in this case, we can leave the area in centimeter squared as long as it's the same on both sides. It's a ratio. So you have 8 centimeter squared times the speed there is how much? 250 centimeter per second is equal to the area on the other side is 3 centimeter squared times the speed which we are trying to find. Now when you rearrange that and calculate, you get 667 centimeter per second, which in meter would be 6.67 meter per second. Alright, now to find the pressure, what do? We apply Bernoulli's equation. And because it's a horizontal pipe, you only need the pressure energy and the kinetic energy, because the potential energy will be the same on both sides. So that is the pressure energy plus the kinetic energy for unit mass in one section is equal to the pressure energy plus the kinetic energy in the other section. Well, that is Bernoulli's equation. The total energy is constant. So now we need to find P2. So we have to make P2 the subject, which means you have to take half V1 squared to the other side. This goes to the other side, becomes negative. And to find P2, you'll have to multiply with rho, because rho is in the denominator, goes, and you multiply with rho. Okay, so that is the equation. And now substitute the terms. Density is 1660 kilogram per meter squared. Pressure in section 1 divided by the density plus 1/2. We calculated the velocity to be 6.67. So square that minus 2.50 squared. That gives 1.71 times 10 to the 5 pascals. So that is another question. I hope you understood. We've used the equation of continuity and then used Bernoulli's principle. That takes us to the next question. Here it's about a small jet airplane, has a total wing area of 72.5 centimeter squared, and a mass of 8.03 times 10 to the 4 kilogram. And if this jet is in a horizontal flight, remember the word horizontal again, which means we need not consider potential energy. We got to find the pressure difference between the lower and upper surfaces of the wings. Well, that's about the shape or profile of the wing, and we know that the pressure on the top part would be less, while the pressure on the bottom part would be greater. So that's P1, and P2 is smaller. Therefore, there is a pressure difference upwards. We know that pressure should be, and whatever is the pressure difference acting on that area should balance the weight of the airplane. And the weight of the airplane is mg. And this is what has to be balanced. Now, pressure difference is equal to F by A, because pressure is force by area, and that should be equal to mg by A. And did you get that? Because force is mg and pressure difference is mg by A. So that's the mass times 9.8 divided by the area of the wings, 72.5, and that gives us the pressure difference. 9.80. Okay, so that's 1.09 times 10 to the 4 pascals. That's a huge pressure difference that keeps the airplane in flight. Alright, this problem has a second part. Let's look at that. In the second part, it says when the speed of air traveling over the wings. So that's going to be V2. 247 meter per second. Find the speed of the air under the wing. And the density of air is 1.29. Okay, obviously we have to use Bernoulli's principle once again. So the pressure energy plus the kinetic energy on both sides must be equal. Remember, we're not using the potential energy because it's horizontal, and on both sides it will be equal. Therefore, since we have to find V2, we're going to make that the subject. First I took P2 by rho to the other side, and now take rho onto the other side too. It becomes rho by 2. This is the 2 there. Into this. And we already calculated the pressure difference as 1.09 times 10 to the 4. So put that equal to the density of air divided by 2. And V2 Okay, V2 is given, we're trying to find V1. Because we have to find the speed under the wing. And that is what we have labeled as 1. So, I just forgot to write V1 squared here. Obviously that is V1 squared. And so V1 squared is this, and V1 is 154 meter per second. Look at the big difference between the speeds. On top of the wing, it's 247. Under the wing, it's only 154. So where the speed is smaller, the pressure is greater. That is what keeps the huge airplane and all those people in it in flight. A wonderful application of Bernoulli's principle. Takes us to the next problem. A cylindrical bucket sitting on the edge of a table has a small hole. It's only 3.30 millimeter diameter. Water squirts out through the hole as shown in the figure. Height of the table is 1.25 meter. Find the height h of the water level in the bucket. Okay. The figure, small h, that's the depth of the liquid, and this whole container is kept on a table of height caps h. Water squirts out through that point and falls a distance of 0.800 meter. Okay. Using the equation, half is equal to, h is equal to 1/2 at squared, because the initial velocity is 0, the vertical, it's coming out vertically, so the horizontal initial velocity is 0. At this point, it's coming out completely horizontally, so initial vertical velocity is 0, so, or to find h, we use h is equal to 1/2 at squared, where obviously a is 9.8. So you can make t the subject and you get square root 2h by a is 2 times the height of the table, 1.25 meter, divided by 9.8 meter per second squared. And that gives 0.255 seconds. So, square root of that. 0.505. Now, since the horizontal displacement must be equal to the velocity with which water comes out, multiplied by the time, because velocity is a constant, it's horizontal. From there, we can find out the velocity with which the water actually comes out. And for that, divide these two numbers, and that gives 1.58 meter per second. Now we can use Torricelli's theorem, according to which the velocity with which the liquid comes out is square root 2g times the height of the liquid. Rearrange that to find the height of the liquid. Obviously, the 19.6 is 2 times 9.8, and you get 0.127 meter. And I hope these problems have helped you do your assignment. Thank you and good luck.